Hi, good morning, everyone. Welcome to day 2 of general sessions at reInvent. My name is Saji Matthew. I'm a solutions architect at AWS, and along with me is Christian Beechin, CTO and co-founder of Sumo Logic. And today, what we're going to do is talk about how to design for SaaS on AWS. So we have a lot of material for you. We're going to start by talking about some popular SaaS architectural infrastructure approaches. Then we'll dive into a SaaS reference architecture. Then we'll talk about some best practices for designing your SaaS solution. And then Christian will dive into talking about his experience on building and evolving a SaaS offering on AWS. So as we've seen over the last few years, software delivery is rapidly evolving. Initially, we were used to having bits shipped to us where we would procure hardware, data center space, install, configure, maintain, backup, and patch. But that's giving way to much more favorable and agile solutions. Today, you can have your applications hosted either by the vendor, or you can host it yourself or by a partner. You can have the application hosted in AWS and gain some of the advantages of cloud. But ultimately, the solution that we want is to have a fully shared SaaS platform running on AWS, and that's what we're going to focus on for the rest of the session. So there's no single right way to design a SaaS architecture. It's largely dependent on where you are today, whether you have an application ready to go or not, your constraints such as cost and resources and your timeline. But we've seen a lot of different approaches over the years, and I'd like to talk about 3 of them that we see most commonly with our customers. The first is the most approachable and easy to implement if you have an existing application, and that is the isolated customer stack, where you simply spin up a dedicated stack for each customer that is on your platform. On the other end, we have a pure shared services platform from top to bottom. And in the middle, we're seeing a newer pattern emerge over the last couple of years with the emergence of Docker, and now with support from AWS with the EC2 container service, the use of containers to slice compute and dedicate that to your customers. So let's dive in and take a look at each of these in turn. On the right-hand side, you're going to see a number of common SaaS services that we'll dive into. But for the next few slides, we'll just look at the provisioning and metering part and how it relates to the 3 common approaches that we're going to examine. For the isolated customer stack, as you can see, it's fairly straightforward. Every time you get a new customer, you simply launch a new stack. And you tag all the resources that you're going to be dedicating to that customer with a unique customer ID. In this example, we have a tag called Cost Center, and that's tagged with the customer ID of customer 1. This information will flow into your AWS billing report so that now you know exactly how much to charge that customer. So it's very straightforward. And this application needs to have no knowledge that it's running in a multi-tenant environment because it's simply serving a single customer. As you onboard new customers, you simply can launch a new stack for them, and with AWS CloudFormation, this is very straightforward to do so. So there are a couple advantages to this besides the ability to launch an application quickly with minimal to no coding changes. Most applications will be able to take advantage of services like elastic load balancing, multiple availability zones, auto-scaling, and maybe other services such as RDS. Additionally, if you have customers in highly regulated industries where they typically demand an isolated stack, this could be a good approach. But there are some serious drawbacks with this approach as well. If you have thousands of customers, you're going to have thousands of stacks, and you're going to have to deal with infrastructure sprawl. Another negative is that your utilization across all of these stacks is going to be the least of the 3 approaches that we'll talk about. Additionally, you may be tempted to tweak a stack for a given customer, which will also cause a lot of unintended problems and consequences. And finally, deployment becomes more of a challenge because with 1,000 stacks, you have 1,000 places to deploy your code on a daily basis. And so let's take a look at another option, which is containerization. Containerization is a refinement of the isolated customer stacks, and instead of dedicating a single compute instance to a customer, you can slice up compute instances in the form of containers and dedicate that to several customers. In this example, we have two customers. Customer 1 is dedicated the blue containers, and customer 2 has access to all of the yellow containers. If you want to add another customer or add more capacity for existing customers, we can simply coordinate that with the EC2 container service. So the advantage to this option is greater utilization and less infrastructure sprawl. And the challenge to this is that metering becomes a little bit more complicated. Now you'll have to bake in instrumentation and metering code to various parts of your application. And so that could take longer to implement, but this is definitely an option to consider if you are developing a newer application and you don't have to make that many coding changes. Ultimately, what we want to advise customers to do is to get to the shared platform option where all customers share a single platform. This is the approach that you should take if you are developing a brand new application from the ground up on AWS. If you have an existing application, you may want to evolve it over time to reach this end state. Here we can see multiple customers using things like AELB, various instances in the front-end web fleet, as well as instances across the application layer, and finally, the database is shared amongst all customers. The challenge here is that all parts of your application now need to be multi-tenant aware, and so this could require a lot of changes for an existing application. But if you're developing a new application, this is something you'll just build in naturally. The advantages are you have a single platform, and that means you can benefit from economies of scale. It becomes very straightforward to provision. There's no explicit provisioning step. As you onboard more customers, auto-scaling and other techniques can simply add more capacity as you need them. And deployment is fairly straightforward. You simply can deploy to a single infrastructure instead of many containers or many isolated stacks. So now that we looked at a number of different infrastructure approaches, let's dive into a SaaS reference architecture. So don't be afraid, this looks like an explosion of AWS icons, but we'll explain each of this very quickly. So as you can see, this reference architecture is composed of 4 major areas: your application, resource management, business services, and core platform services. So your application is the star of the show, and everything else is the supporting cast. And so with your application, you may have a single application today, but over time, you may develop a portfolio of applications that are presented as SaaS offerings to your customers. The most important thing you can do here is not build a monolithic application that mixes in all of these supporting services into your application code. Instead, you want to use best practices such as service-oriented architecture and loosely coupled application components to develop something that can work independently of your application. So let's dive into the top left, which is resource management and the ordering components. With ordering, this is the entry point to your application, and how your customers reach your ordering pipeline will depend on things like your existing marketing efforts. You may have a page on the AWS Marketplace that will redirect a customer to your ordering page, and it will integrate with billing, analytics, authentication, and authorization components within this architecture. You can use several AWS services to help you build out the ordering portion of this. You can use simple workflow if you have a very heavy-duty, complex orchestration required for onboarding new customers. Or you can use something like SQS for something a little bit more modest. Next, we have provisioning. Provisioning is the ability to fully automate deployments of your infrastructure. And as we saw with the first 3 approaches to designing your SaaS architecture, that is going to depend on which approach you take. But generally, what you want is a completely automated deployment that has really no manual intervention. And when you develop applications on AWS, you're going to capture the infrastructure in the form of a CloudFormation template that you can use to deploy your dev, test, staging, and production environments. So once you have CloudFormation in place, it becomes very simple to launch dedicated instances for your customers if you have the dedicated instance approach, as well as provisioning development environments and within a single region, as well as going multi-region if you decide to go that way. So some of the services that you can use besides CloudFormation include AWS OpsWorks, Elastic Beanstalk, and of course, if you decide to use the container service option, EC2 Container Service is something that can be helpful here as well. Next, we have application lifecycle management. And this is one of the biggest changes when people move from an on-prem development mindset to a SaaS mindset. With an on-prem option, you have the development life cycles that could take months or maybe years. With a SaaS application, you may do multiple deployments per day, certainly per week, maybe months as well. But what you need to do is to really engineer your deployments so that new deployments are seamless, they don't cause disruption, and they're completely transparent to your customers with no downtime. And so there are various ways to get here. You can use various open source and commercial options, as well as a suite of AWS tools such as Code Deploy, which can help you deploy your new code to various instances and help you roll back in case there's a problem. In addition to that, you can use Code Pipeline to orchestrate your development process, as well as Code Commit to host your repos. Moving on to the business service portion of this, first up we have billing. Billing aggregates customer usage data and presents a bill to the customer for payment. Think about how AWS presents your bill. It provides a lot of granularity in terms of the services that you use. Whether you choose to go that granular or not really depends on your application, but ultimately you can use that as a model to kind of to determine how you should present your bill and what sort of data you want to capture to present to your customers. So there are a lot of third-party options that you can use for not only billing, but various other parts of this reference architecture. And so one thing I want to call out is that you don't have to build all of this stuff yourself. You can certainly leverage other SaaS solutions to help you get to market a lot faster. So some of the services that can help you here are DynamoDB to store your billing information, and EMR to help you generate and to actually calculate and generate the bills. Next, we have analytics. And this is also one of the fundamental differences with SaaS solutions in that now you can collect a lot of metrics that will give you great insight into exactly how your customers are using not only your application, but the platform itself. And with that information, you can do some deep analysis, which can drive decisions on what sort of features you present to customers, how to improve your infrastructure, and so on. So let's take a look a little bit more deeply about how analytics should work in a SaaS offering. You can see on the left-hand side, you have various data sources. These could be your application EC2 instances, these could be your containers, and these could be various databases that hold application, metering, and billing data. And so you should have a plan in place to rotate your logs and put them in durable state, such as S3. You can also use AWS Code Pipeline to move data from your databases and store that in S3 as well. Once you have it in S3, you can leverage things like EMR as well as Redshift to do data analysis. You can also take advantage of machine learning service as part of the AWS platform to give you insights into your data as well. Once you have the data that's processed, you can now present reports, both internally to understand what's going on with the platform and usage of the service, as well as to your customers. So you can take advantage of the newly introduced QuickSight product as well here to generate reports easily. And of course, you can present that to customers, and you can present not only reports, but you may want to think about presenting a query interface for deeper analysis that customers can take advantage of. So now if we move on to the core platform services, we have authentication and authorization, which should be very self-explanatory. And think about how AWS implements this. You have a master account. From there, you can create numerous IAM entities such as users, groups, and roles. Now, whether you want to take that approach or something simpler is completely up to you, but the idea is that you should have an independent identity store that can be leveraged by your single SaaS offering today or multiple SaaS offerings tomorrow. And of course, you want this to integrate with existing identity stores that the customer may have and third-party options as well, and you want to provide a single sign-on option also. So some services that you can use include AWS Identity and Access Management to give granular access to various AWS services. You want to think about using KMS, Key Management Service, to hold the keys that will encrypt data for either the customer in its entirety or various users within that customer base. Cognito can be useful for web and mobile authentication, and you can take advantage of directory service so you don't have to manage EC2 instances for your directory services. And then finally, RDS could be the host for your custom authentication and authorization stores. Moving on to monitoring, this is a very critical piece of any SaaS platform in that it is what will basically give you an idea of how healthy your platform is, both at the business level as well as the infrastructure level. And so what you want to do is to ensure that this is scalable and that as your application requires, you can scale this monitoring piece easily and quickly as demand fluctuates over time. You can, again, certainly take advantage of third-party options here. There's numerous vendors in this space. And as far as AWS services, you can use Kinesis Streams to get real-time data from various parts of your application. And you can use CloudWatch to get access to various metrics about the infrastructure that hosts your SaaS solution. And finally, we have metering. Metering is the ability to understand customer usage and activity within your SaaS solution. It is what basically is going to be used by various parts of your SaaS solution, such as billing and analytics, to give you insight into what's going on within the platform. One of the key features of your metering platform has to be auditability and traceability, so that if a customer has a question about why they were billed a certain amount, you can certainly give them auditability about how that particular line item came into their bill. So some options for this, let's dive in and take a look. You can see that on the left-hand side, you have a number of different data sources, such as S3, Kinesis, Dynamo, and RDS, as well as application instances. All of these data sources can generate metering data. So if you want to generate metering data from these data sources, such as these databases, we can leverage Lambda. Lambda can be called by any of these sources. They can trigger a function that can pass in data and generate a metering message. And of course, the application instances can generate these metering messages all by themselves. Once these messages are generated, they can be put into a simple queuing service queue. That queue can be leveraged by your aggregation engine, which can be implemented in EMR. It could be implemented as custom code in EC2 instances. But once the metering data is aggregated, it could be stored in Dynamo. Once it's stored in Dynamo, you now should have a service that can make that information available to other components of your infrastructure, including billing and analytics. All right, so now you looked at the architecture, we looked at different approaches to building out the infrastructure. Let's talk about some of the best practices that we've learned over the years from customers who've built SaaS solutions on AWS. The first is to separate the platform from the program. And what I mean by this is that you should consider a service-oriented approach where each of the components that we talked about can run completely independent of each other, and it should not be tightly coupled with your main application. The reason for that are numerous. First, your applications will evolve from the supporting platform independently. You can reuse these supporting services for various applications that you may implement over time. You'll be able to scale these parts independently of each other. So there may be times when the metering component will require more resources. So adding more resources to that should not have any impact on the rest of the application. So you can scale independently and have much better cost effectiveness for the entire platform by making all of these parts independent from each other. You can optimize for cost and performance, which often seem to be at the opposite ends of the spectrum. With AWS, you have a variety of different storage and compute options. They have different price points. And so you can offer your customers various levels of performance based on their sensitivity to price. So for example, you can have a free tier, you can have a premium tier. The premium tier may use the highest end services, such as the largest instance sizes, along with the fastest storage, along with the lowest latency databases. The free tier will use exactly the opposite. It'll be maybe a best effort implementation, where you will use maybe the burstable instances such as a T2. And maybe you want to think about using magnetic storage for EBS. And so you can come up with various options that give customers a range of cost and performance. As long as you set the expectations with customers correctly, this should be fairly straightforward to do. Another best practice is horizontal scaling at every layer, and I think this is a common and well-known principle for AWS application design. The third is to create smaller, more parallelizable units of work. So the idea behind this is not to create something that will use the largest box possible, but rather something that can be easily horizontally scaled. And finally, leverage inherently scalable services such as Dynamo, Aurora, and others, so that as your customer base grows, you can easily scale up, and there won't be a bottleneck in any part of your application architecture. So for example, with Dynamo, whenever you need more read or write capacity units, it's simply an API call away. When you design a SaaS solution, you have to think about multi-tenancy. When you have an on-prem solution, you are designing it for a single customer and that customer's user base. When you design a SaaS solution, you're designing for thousands of customers and all of their users. So you're dealing with an order of magnitude of complexity. And this has vast implications for your entire application, from the application code all the way to the database schema. So you can imagine that the database schema for an on-prem application would be a lot simpler than the one for a SaaS application. So for a SaaS application, the schema will include not only users, but customers as well. You can provide tiers for request prioritization. So going back to the earlier example of a free tier and a premium tier, perhaps the free tier, those requests will go into a low priority queue. And that queue may use spot instances, very low cost spot instances. And then for premium customers, it'll go into a high priority queue, which will get executed as necessary to maintain a certain SLA. It'll again use the highest level of services from EC2, EBS, and the database services, so that essentially your premium customers get the best service and other customers, ones that are free, can get a best effort service. And obviously you want to monitor the infrastructure closely so that you can understand what activity is happening and then allocate resources not only at the business level, but at the infrastructure level. A key principle of SaaS design is understanding the life cycle of your data. With an on-prem solution, maybe you will store all of the data in a relational database. On AWS, you have many more options, including databases, S3, Glacier, and so on. So now you can design an application that is much more cost-effective and tuned to how your customers really use and access data. So perhaps your customers will access, most frequently, the first year's worth of data. The rest, they may never access or may infrequently access. So you can set up policies so that you age data from a relational database onto perhaps S3. S3 has a little bit greater latency than a relational database, but certainly you can set that expectation with customers if indeed they infrequently access that type of data over the years. And certainly you can leverage S3 standard the new S3 infrequent access option, and eventually you can take advantage of Glacier here as well. So what this does is make your design a little bit simpler. It'll reduce the size of your relational database, and then make it much more cost effective to offer different types of storage to your customers transparently. And finally, we want to collect as much data as possible and learn from it. And what we mean by this is that with a SaaS solution, you can monitor exactly what your customers are doing at any one time. So you can understand where or what features your customers are using the most, where they're getting stuck, what features add no value, and this can drive decisions on how you evolve your application. So you can allocate resources much more intelligently than ever before. And essentially, by collecting and analyzing the data, you can learn and profit through using analytics. So, and you can monetize this by understanding exactly the usage of the application by your customers, and then thinking about perhaps new products that can meet a gap that your solution may have today. So with that, let me now turn it over to Christian, and what he's going to do is talk about Sumo Logic, how it was designed and evolved over the years on AWS. Take it away, Christian.
Thanks very much, Saji. Yeah, give this man a hand. Where were you in 2010 when we started Sumo Logic? I wish I had known all of this stuff. I wish we had known all of this stuff. We were thinking about building an application. We were not worried about billing and metering and all of these things. So, all right, so Internet of Things, huh? Very exciting. All the chairs are instrumented so we can get real-time feedback for each slide, how your butts are shuffling around. So, all righty, so who am I? I'm one of the founders of Sumo Logic. I'm also the CTO. I have been dealing with logs and log analytics pretty much throughout my entire career for the last about 15 years. What does Sumo Logic do? Sumo Logic basically picks up this thread that Saji was talking about at the end of his presentation around monitor everything and learn from all the data. And we do that by giving you a way to put all of the logs and metrics and so forth of your that get generated as your applications, your SaaS applications, your on-prem applications, new, old, whatever it is, in the cloud or in your data center. We make it so that it's very easy for you to put all the data in one place, and we provide the analytics on top of it. It looks roughly like this. It's pretty obvious. It's a cloud-based platform. The data can come from anywhere, whether you're in the cloud or not, doesn't really matter. The use cases that we support, range from DevOps to, IT ops and also compliance and security. What we hear from our customers is that, in today's age, with Moore's Law and connectivity and all of these things, there is a need to continuously innovate in order to stay competitive. IT supports that, obviously, technology, networks, etc. But as technology takes over the business, things also to some degree can get more complicated, more distributed, more external services being used, and we provide visibility in all of this. And what we actually furnish to our customers is a way to be continuously intelligent. All right, enough about this. Sumo Logic is SaaS. Why is Sumo Logic SaaS? Because, and I can say this because I've been there, enterprise software just plain sucks. Too much pain for the customer. I lived through this for 10 years. All we ever did, we talked to our customers about how to run the system. We never really talked to them a whole lot about how to use it. Eventually you realize that there's something wrong there. And of course, this is something that is, that's not necessarily new. Everybody goes through their own evolution of how they come up, realizing this. Something that I have not heard a lot of people talk about is, and this is also from my experience, it is actually disastrous for you as a vendor as well. Every time you release software that leaves your control, that software will not go away, and it will continue to track you down year after year after year. up to the point where you cannot innovate anymore, because all of your resources are spent updating old branches, backporting fixes, and not actually building new versions. And even if you build new versions, people will not actually deploy them because of number one, it's too fucking hard. So, why did we choose in 2010 when we started Sumo Logic? Why did we choose AWS? So we're developers, that's our background. We know nothing about data centers. We wanted to build a service, we knew it was going to have to scale, not just to the largest customer, but really to all customers. And so, hey, AWS has turned the data center into an API. As a developer, that's something that I can understand and I'm comfortable with. And anyways, the developer mindset is reuse. We've used, we don't write our own OSs anymore, at least most of us don't. We don't necessarily, re-implement the standard libraries, at least most of us don't. We are actually used to this idea of reuse. AWS just puts that on a different level of abstraction. Now you're reusing a data center. So, I want to go through three things, three major areas, or three sort of tenets that are actually important for us and that I want to share with you around how we think about building a SaaS application and some principles that we think are important. And the first one is, it can't be monolithic. There's a lot of talk about these days around microservices, etc. A lot of people say, hey, don't factor out too much until you know what you have to do. In our case, we actually knew what we had to do, or at least we were foolish enough to think that we knew, and because we had built a similar product before. We were not looking for an MVP. We knew this thing had to scale. So from the very beginning, we had a logical breakdown of the system pretty much right away. So I'm going to show you this high-level logical breakdown that in many ways actually maps to the services that we have actually factored out, and I'll show the detail of this in a little bit. Our system, as a log analytics platform, needs to ingest a lot of data. This is our ingestion path. We receive the data from the internets. We have some sort of bus kind of thing there. And then, we process the raw data and we shove it into S3 so it's there and never gets lost, and we encrypt it and all of those good things. We run a fleet that does all of the indexing. Since we deal with semi-structured data, the full text indexing is basically our database. And then we run continuous queries. Continuous queries run in real time, updating aggregates. Or in other words, what was earlier announced, on top of Kinesis. Unfortunately, we didn't have that in 2010, so we had to build it ourselves. The continuous query engine uses S3 for snapshots because, ultimately, there are chances that you lose a machine and maybe state, and so you can snapshot it into S3 and then pull it back as part of the analytics part, as part of the analytics path. What else is there? Well, there's a query engine. We have to basically pull the data out. We have to use indexes and other things in order to answer your queries, in order to give you the analytics that you need. And then there is a service that basically, that's a service. It's a great name for that we came up with, that basically interacts with your input, API, UI, and so forth. So that's kind of the high-level breakdown of our system. This has, at this point, reached a scale of 50 terabytes of new incoming data every day. We continue to scale in a superlinear fashion. I was here talking about our system last year in November, so it's 11 months later. Last year, I was talking about 15 terabytes of new data per day. And I promise you that was the largest number I'd ever seen in my life. It just keeps growing. It's obviously good. We are actually in 4 instances. We have sort of 4 different deployments across the world. That's another thing that you get basically for free with AWS, actually. You can go into Europe, you can go into Asia Pac, etc. So, principles of scaling. If you build a SaaS, you need to have some handle on scaling. Ours is a data platform, so scaling becomes even more important. But even if you are not crazy enough to actually think that you can just shove all this data through your system, in some way, shape, or form, you will have to scale. There's a great book out there called The Art of Scalability that was actually out in 2010. And I really wish we had read it a little bit more carefully. But we came up at least with 2 of the 3 dimensions more or less on our own. So the x-axis here in the sort of scaling cube here is essentially horizontal scaling, right? So you have something that does something, and you make it so that you can go from anywhere between 3 to thousands of replicas or instances that all do the same thing. So I think that's called horizontal scaling. Don't use just one box and hope that everything works. Make it so that you can actually scale it out. I think pretty much everybody has picked up on this by now. The other thing, and that's the y-axis here, that's a little bit more interesting. Functional decomposition. So basically, try to figure out what are the components of your system, and can you actually keep them separate? So that sort of maps back to the sort of high-level architecture of our system that I showed you earlier. Why would you do that? One reason to do it is to decrease your blast radius. There's a very martial term of looking at it, but if stuff basically blows up, and it will, then you can try to you don't want the entire system to fail. Make it so that probably only a part of the system fails. And maybe the rest of the system will sort of continue to limp along, still better, than not having anything at all. It's about separation of concerns. And from a developer perspective, that makes a lot of sense, because in many ways that's how we've been trained to build systems even before we deployed them into data centers of unlimited size. Not everything will break all the time. You will not be able to ever rewrite the entire system, and you do not want to get stuck with having to change the entire system if something fails. So the way that we talk about it is, the plane's flying, it never lands. We have some magic plane that never lands. We need to repair the engines in flight. If you are building a SaaS service, that's what you will end up having to do. So if you make the thing smaller, there's less impact, and you can basically get closer to where the actual problem is. You can change the engine in flight. You do not have to reconstruct the wing, just to stay with the metaphor. And finally, and this is kind of from a human systems perspective is very interesting as well. If you have the concern separation, if you have the functional decomposition, they can also actually help you scale your development, because now not everybody necessarily needs to know everything in your organization. People can be experts of a particular part of the system. They provide interfaces, and they interact with the other guys' interfaces as well, and that gives you ultimately more parallelism, and you can build stuff more quickly. So that's also known sort of as the, if you can pull this off well, it's also known as the reverse Conway maneuver. So you're basically putting your organization together around the functional decomposed architecture. Alrighty, so what did we actually do? We actually were smart enough to figure out that we needed to compose the applications that make up the entire SaaS from layers of modules. In our case, we've done a lot of work in Java before. We were comfortable with the JVM as a platform. We were a little bit bored with this whole Java thing. So we decided, let's use a totally unproven, new research language called Scala to build the next thing. And that actually worked out really well. I'm not sure I can recommend, that train of thought necessarily. But for us, it worked out well. Attracts a lot of talent. People want to work with new stuff, and that was kind of the thinking. It's in Java or Scala. It's a JVM based, so of course we're using Maven. Each module has a POM, as you would expect, and modules compose into applications or services, and there's a main method for those services, so it's pretty simple. We initially had separate Git repos for every service. At the point, or actually for every module, at the point where we had even relatively early on, we already had 40 to 50 or so different modules. Making any change to the system required often, to touch more than one module, because maybe you're changing some interface and you need to make the change on the other side as well from the API perspective. It became pretty hard To do that, it's okay to do it locally, but then try to give somebody a pull request that spans multiple repos. That ended up being basically a nightmare. So we ended up ultimately making one repo that has all of the modules in it. That's kind of where we ended up. For each application, again, remember the graphic that I had before, all of these like components, these are all applications. We ended up basically turning each of these into their own cluster. So we have 3+ of each of those. And what that also helped us do is kind of right size the instance type for the type of cluster, more CPU, et cetera, the usual trade-offs. And then for what it's worth, we're using ARC304 over HTTP for RPC, and that's also what we run over our messaging infrastructure. We use a lot of Hornet queue because there was no Kafka and there was no Kinesis in 2010. We're looking very heavily into, and in fact, we're actually starting to deploy a replacement for the underlying kind of messaging infrastructure that's based on Kafka. So basically what I've been trying to tell you is that this whole microservices thing is actually a pretty good idea. Because you will find, when you're successful, that you need to have the flexibility. You need to be able to divide and conquer. So that's how I actually visualize microservices. So, and here's our services incredible mess and Death Star, and you've seen this from a lot of other companies. We're not quite yet at Twitter scale. We don't actually have 200 different services. We still have this idea that probably not every single line of code needs to be its own service in its own container. But there is definitely a lot of breakdown going on here. And in these little boxes, you will see some of the higher level functional components reflected, because that's really where we started from. And this is a living, evolving system. We never set out to rewrite the entire thing. We never will. But in many ways, it's being rewritten, as we go. Again, everything gets deployed on at least 3 machines, and some things get deployed on 3,000 machines. One thing that's important if you have the microservices or service-oriented architecture is that you do not actually equip the individual applications or services with any knowledge about the environment that they are in a static fashion. That has to be dynamic. And this is, again, also not necessarily something that you haven't heard before, but I want to stress it because it's really important. From the very beginning, we thought that each of the applications or services should literally not have some sort of config properties thing, or some gnarly old XML that's sitting there telling it what to do, that you have to somehow parse in when you basically start the application. This is how we start a service in Sumo. We simply give it one parameter and only one parameter. And that parameter points it to where the service registry is. The service registry, in our case, is built around Zookeeper. That seems pretty obvious given when we started and the fact that we are JVM-based. There's other options. For example, CoreOS, with etcd, et cetera, have all of these things already built in. That's just how important that idea of a service registry is and a distributed system like that. And it's not the hardest thing to build, especially not if you have some good consensus kind of tool like Zookeeper or etcd, et cetera. All right, so now the second one, the second main point. We truly believe in multi-tenancy. This also came out in Sachi's part. So if you are starting from a clean slate in particular, go with a multi-tenant approach. It will be a lot better. It is actually going to keep your costs down to some degree because you have less slack, and I'm going to go into that in a second. And also, you really want to make sure that you do not do any sort of customization on a per customer basis. If every customer is a single tenant in your system, what will happen is that they're going to call you up and they're going to say, oh, but can you change this, or maybe can you make this UI change and revert it, and you're going to go, and ultimately you're losing control, and ultimately you're going to get tracked down into sort of software kind of on-prem deploy model. So with a wink, we're appropriating this sort of DevOps kind of mantra of cattle versus pets, and I really think that just from a purely rational kind of architect perspective, you really should think about your customers as cattle and not as pets. It'll get you into a lot of trouble otherwise. So now, of course, there's a bunch of our customers in here. And so, how we really really actually feel about you guys is like, that's kind of how we visualize you. Of course, nothing will ever be the same across two customers, even if you have a multi-tenant system. So you will end up introducing dynamic configuration and feature flags and so forth. And there's really not a whole lot of things that you can do about that. You will end up having to do it. And so the cattle will all essentially run around with their own configuration of feature flags in a large system that can get pretty complicated. If you go down the route of feature flags, which you will have to, make sure you have good introspection tools for those. Otherwise, on a per tenant basis, the system behavior might just, kind of change a little bit, and it'll sometimes get really nasty in terms of debugging. All right, so everybody here is a Sumo customer, I hope you don't take this too seriously. So, especially for us as a data platform, why is multi-tenancy going to be more efficient? Well, here's a typical Sumo Logic customer. There's literally an 8x variance in the amount of data that's being sent, 250 gigs all the way up to almost 2 terabytes. Right? If you're building a single tenant system, you're basically going to provision that system, especially if it's on-prem, but even if you're building a single tenant SaaS, you have to have some sort of static provisioning for this. And you are going to waste money. Right? You can think, hey, I'm going to build, the world's best auto-scaling controller, and I'm going to dynamically, put everything and make it go up and down. But the reality is that in a system like this, where the data comes in real time, that ends up getting pretty hard. Your controller is going to be a very complicated piece of logic. And I've read the control theory book, and I thought that I can write the best PID controller there is, and guess what? I can't. Because of the laws of physics and the fact that, just because you think you need capacity, AWS gives you this capacity potentially very quickly. But it still takes on the order of, seconds or minutes and not microseconds. And so controlling that in a closed loop gets really, really hairy. So the load per tenant fluctuates wildly, but the aggregated system load, in our case, because all of these things cancel each other out, ends up actually just growing slowly day over day. So believe it or not, our system from the outside actually ends up being provisioned rather statically. We don't do any wild auto-scaling. This is the third of 3. Your data center is now an API. Do not do anything manually. Use automation to the fullest extent possible. This is actually, to some degree, easier said than done. We, of course, use Jenkins. You can pull whatever CI tool you want to use. That's fine. We still build system versions, actually, that we deploy as crosscuts across all the modules because we feel that we need to test them together. So even if you have microservices, you can still end up in this sort of trap of having a monolithic microservices thing going on because you feel that you need to deploy them all together. We are working now, and this is really something that after the fact gets a lot harder than if you do it right away. We are working now on basically making smaller groups of services that sort of evolve together, and we're going towards continuous deployment and delivery for those in a smaller step. If you have a greenfield opportunity today, don't start with this idea of having to have a cross-cut system version across all of your services. It'll slow down your deployment processes because everything has to be tested together, et cetera. Try to go for the continuous delivery approach on a per service level right away. Here's how Jenkins looks like in our case, just like throwing in some pictures here. You can see there's lots of stuff, lots of different modules. They keep getting built all the time, so it's a really busy system. Jenkins, for example, you can set up with Elastic slaves, put them on spot instances, et cetera. Use more rather than less. You can parallelize everything runs much faster. We have a 4-step process to get something into prod. Everything gets put on night, which is a nightly deployment. System versions that we actually think work well together get pushed to Stack, which is our QA department deployment, and they will be able to test it there. And then if it actually comes back out of that, okay, we push it onto this deployment that's called long, which is our internal deployment that we use every day in order to run Sumo logic, and that's the deployment that gets all of our production logs. So everybody at Sumo is always using this last stage deployment, and then we push to prod. We did a lot of tooling. It's our deployment tool. It's called DSH. Again, in 2010, we did not have sort of the abundance of tools that's available today. Our chief architect, Stefan, who's actually sitting right here, spent a lot of time and invested a lot of love into actually building us a command line deployment tool that knows how to basically do everything in AWS and knows how to do that with our code base. And that is based actually on a model of how our system is supposed to work. The fact that it is actually model-based is something that I have not seen in a lot of in a lot of deployment tools yet. But that actually turns out to be an entire talk in itself, so I'm not going to actually dive into this very much. All right, so now we're back to the reference architecture. And looks like somebody at AWS really likes Minecraft, looking at all of these logos. So let me map onto this reference architecture, kind of, which parts we use and, what we kind of use for the individual concerns here. So we use ELB, of course. In our case, we have 3. One for service, which is the API that our user interface talks to. Then we also have a published API. That's another ELB. And then ultimately, of course, we need to ingest all of this data. And that's a bank of what we call receivers. And those are behind ELBs as well. So that's pretty obvious. As far as the application is concerned, of course, we're using EC2. We're obviously using reserved instances. In our case, because it turns out, and that is actually counterintuitive, and we were not really prepared for this in the beginning either, but it turns out that because of the cancellation of the various fluctuating loads, the system is actually relatively statically provisioned. It turns out that we can actually get a pretty good saving with our eyes because there's not all that much dynamic sort of instances spin up, spin down going on. And of course, we like looking at Spot as well. Spot is really interesting. In many ways, I think of Spot as this idea of unreliable distributed systems, thought all the way through. So if you want to really, really have a reliable system, make sure you develop it such that it can actually survive running on Spot instances, and then it's pretty much going to be perfect. We use the simple email services in order to send emails to our customers, alerts, and all of these things. Sending emails these days is very, very tricky. You don't want to do it yourself. You're going to get caught pretty much in all the spam filters, and SES fixes that. Simple queuing service is actually used, Sachi referred to that earlier, for user registration from the corporate website. So when you go to www.sumologic.com and you sign up for a free tier or free trial, we need to do some provisioning work, of course, and that comes to an SQS queue. We have basically, as I said before, double-digit petabytes of S3. S3 is a fantastic system. The amount of, the amount of durability really that we get out of it is basically game-changing. We do not have to worry about losing the system of record data, basically. So that's a fantastic benefit. We use Elasticache Memcache in order to populate client caches for guys who basically talk, well, one service talks to another service about customer data or whatever it is, internal configuration data. So Memcache is used pretty heavily there to make it so that we don't have to constantly call the backends. I'm still trying to find a way to get Redis in there because I love Redis, but I'm apparently the only person at Sumo that does. So right now we're doing Memcache. We use DynamoDB, not very heavily, but we put the feature flags in there and all of the configuration stuff, and it also acts as a journal for one of the metadata services. And that was clearly over-designed, and because you don't really need DynamoDB. I mean, DynamoDB is a nice system and all, but if you need a journal, just append to a file. And so, of course, when there's a hiccup in DynamoDB, as apparently there was a little while ago, we were not entirely unaffected by that. all of the configuration and content objects, the system configuration, organizations, users, searches, queries, etc. That's all in MySQL via RDS. We use SimpleDB a little bit for a simple deployment locator. We have a Yellow Pages service internally that basically tells us where is this customer, which deployment. We just club that into SimpleDB because it's easy. Monitoring, well, guess what? We're using our own tool for that. I would encourage you to think about doing the same. We also use CloudWatch and CloudTrail. For analytics, again, we happen to have an analytics platform lying around, so we use it very heavily. We're really lucky, actually, because we have an almost perfect dog fooding scenario, which not a lot of folks have. We use Sora for billing. Sora is another SaaS, so there's nothing wrong with using other people's SaaS, to do stuff for you. Sora is pretty industrial strength in terms of billing. Lifecycle management, Jenkins, I've already said. We're using GitHub. Everything's in a private repo. Provisioning goes through the stuff that we build ourselves. I referenced that earlier as well. This is not something that you probably are going to go down that route of these days. There's probably better tools that you can get you there more quickly. We're starting to, for a new project, we're starting to look at Mesos. We're using CloudFormation. They have some pretty nice CloudFormation scripts to set that up, so that's cool. And that was pretty much the mapping. I want to toot my own horn here just a little bit. We actually have integrations with a lot of the AWS services that spit out data. I think that's really cool. They're listed here, so we can basically ingest from S3, all of the audit logs, et cetera, that you get, CloudWatch, CloudTrail. We just announced something for VPC flow logs, which is super interesting. So that's kind of how we link back, and of course we use that ourselves as well, with our infrastructure provider, which I think is a really good story. What am I very excited about? EFS, the Elastic File System, essentially hosted NFS essentially, is very cool. Learned a little bit more about that yesterday from the guys who actually build it. Very cool system, so we're looking into doing some work with that. The key management service is super exciting, but also kind of like the topic of key management is, again, that's a whole nother talk, so I'm not going to go into that. Very excited about Docker and Mesos and all of these things. But frankly, I think that AWS already invented the future after containers, even while we're still all catching up with the container stuff, including AWS with the Elastic Container Service. I really think in 5 or 10 years, we're going to be here talking about how to build large-scale applications and experiences of having built large-scale applications on top of Lambda. Thank you very much.
Awesome. Thank you, Christian. A couple of last slides before we break. If you haven't already, please register with the AWS Partner Network, APN. And when you do, you can apply for the SaaS Partner Program. You can see there's a whole host of benefits here. This information is available on the APN Network site, so definitely go take a look at it. Once you join APN, you'll have access to much deeper content than what I was able to present today, including videos, white papers, more reference architectures, and you'll be able to consult with our partner team for guidance on how to build your SaaS solution optimally on AWS. So with that, thank you for attending. Enjoy the rest of reInvent.